Hi everyone. Our topic today is a set of numbers. Okay, let's start. There are a bunch of different numbers and they can be divided into different sets. The first number set in the history of mathematics was the set of natural numbers. So I write here the first number set, natural numbers. Okay. They are used for counting by our ancestors, and that's why these numbers are also called counting numbers. So I write here into bracket counting numbers. Okay. These numbers are designated by this symbol n, and we will use Rousseau notation for denoting a set. So n equals a Rousseau notation 1, 2, 3, 4, and so on. This is a Rousseau form of the set of natural numbers. If we add 0 to this set, we get the set of whole numbers. So the second number set is the whole numbers. I write here whole numbers, and this number set is designated by this symbol W, and W equals a Rousseau notation 0, 1, 2, 3, 4, and so on. The sum of two natural numbers are always natural, and their product as well. But the difference between two natural numbers is not always natural. For example, I write here 3 minus 2 equals to 1. 1 is a natural number, but 2 minus 3 doesn't equal to 1. So the answer of this expression is the element of another set. And because of this reason, we need to expand the set of whole numbers. And if we add the negative numbers to this set, we get integers. We can show it on the number line like this. So I draw here a number line, and on the middle, I have to write here 0. To the right, 1, 2, 3, 4 positive numbers, and to the left, they are negative numbers, -1, -2, -3, -4, and so on. You may have noticed that on the number line, the negative numbers are a mirror image of the positive numbers with 0 in the middle and like a reflection, because the numbers 2 and -2 are the same distance from 0, and that's why they are called the opposite of each other. So 2 is the opposite of -2, and -2 is the opposite of +2. And -a means the opposite of the number a. And the integers are given the designation of z. So z equals Rousseau notation. So on -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on, and Rousseau notation. Yeah, we know that the sum, the difference, and the product of any two integers are always integers, but the ratio of any two integers is not always integer numbers. For example, I write here -2 divided by +2. This answer is -1, and the -1 is the element of integer set. But if I write here -2 divided by 3, I know that the answer is not the element of integer set. So we need to expand our current set, and we add here all the negative and positive ratios, and as a result, we get new set of numbers. A new set of numbers is called rational numbers, and the designation is Q. So a rational number is one that can be expressed as a ratio A divided by B. And where A and B are integers and B is not 0, such as -3.72 or -2/3 or 0.2, and so on. And finally, we can define definition of irrational numbers. Any real number that is not rational is irrational, like this. Negative square root 3 or negative square root of 2 or pi, all of are irrational numbers. So if we show all the sets with a diagram, we get a picture like this. On the center, we have a natural numbers. If we expand natural numbers with 0, we get whole numbers here. If we expand whole numbers with negative numbers, we get integers here. that. And if we expand integers with all the positive and negative ratios, we get rational numbers here, rational numbers Q. And the irrational numbers will be left out here, irrational numbers. And the real numbers will cover all the sets, like this. This is a picture of or diagram of set of numbers.